I've
For
not been
what?
able to do it. I should turn it in tomorrow morning.
But today's the deadline. All right. So today I'm gonna be taking you guys through how to build an AI model that can classify image. So I'm gonna give you like guys like a little an intro to TensorFlow, using TensorFlow to build an AI image classifier, and then by Monday we'll build an AI that can look at images of traffic light and classify traffic lights, like tell us if it is what type of traffic signs, like um stop, move, all those things. So you just give it an image of a traffic sign, it should be able to detect what it is. We'll do that next week. Today we are going to be building an image classifier that can classify things like dog and the rest of the thing. It's going to be a little bit of intro, an eye opener into TensorFlow, and by next week we are going to do more complex things like applying augmentations, rotating. I'll explain dropout. There's something called dropout and a lot of other things. All right. So, and also today's class is going to be really fast because I'm not in the office. I came to buy a laptop, so I'm not left yet. All right. Can you guys see my screen? Can you guys see my screen? Hello. Can you guys see my screen? Sorry, you
No.
can. All right. So I've closed the. So we are working on an image classifier today. All right. Basically, we'll be classifying images. So with TensorFlow. So what are image classifiers? I think last week I told you guys about image classifiers and different between object detections. So image classifiers literally help you like to. So let's say you give it like an image of a boy and a girl, the AI model should be able to classify and tell you um, if this is a boy. You are giving it an image of a man and a woman. The AI should be able to classify it and know that this is an image of a man, for example, right? So let's say in this scenario, if I have something like let's say I have a picture of a man and a woman, picture of a man and a woman, and I pass the whole image like this to our AI model. Our AI model gets the image, use some metrics, convert the image to matrix array, do our gradient descent computation. Then I remember telling you guys what y equals mx plus c for the cos and the rest of the things. All right. Um, and they also tell you guys about linking up everything. So, but what happens basically is we want to build something that if I give it an image of a woman and an image of a man, it should be able to detect that this is a man and this is a woman, which is basically what I told you guys last week. So, um, that's what image classifiers are. Image classifiers more like return binaries detection, like 1 or 0. One meaning it is this, 0 meaning it is that, and the activation function that literally helps us to achieve that most of the times is always sigmoid function. All right. So why TensorFlow? TensorFlow is very easy to use. Normally, would have mentioned things like PyTorch and the rest of them, but TensorFlow is easy to use and to implement. TensorFlow is easy to play around with. TensorFlow is easy to come around with. You know. All right. So TensorFlow is easier to implement than PyTorch, and although PyTorch is used in most robust program, But TensorFlow is just easier. You can understand things more faster, and you don't have to do too much work. All right. So, um, what is image classification? Image classification is a fundamental task in computer vision. It involves automatically assigning label or categories to an image, right? I remember telling you guys about what's it called? About um supervised learning and unsupervised learning. Basically, image classification is supervised learning. Common applications include object detection in self-driving cars. So you see self-driving cars are able like to detect objects, to look at objects and know that this is an object of this and an object of that. Image recognition in social media platforms. So you will see that if like a kid is watching a video that's not appropriate, you will see something like this video has been blocked or sensing whatever thing. That is basic image classification, right? And then medical diagnosing. I can have an example of this. I have a brain tumor detection software belt that could detect brain tumor. Basically, everything I did there was just what I'm teaching you guys today, which is what we'll do tomorrow. A drop, a drop. Can you guys hear me? All right. So basically this is image classification. So what I did here basically was an AI that can pick an MRI scan of the brain and then tell us if there's a brain tumor in the in the scan. In this case, you see. So what I did was just four classes, four labels, um, or just two labels. One of the labels has images that has brain tumor. The other has images. The other category has images that doesn't have brain tumor. And then I trained it over and over and over again until the AI model could look at an image and detect if there's a brain tumor. This is image classification in action. And then um, I was able to use it to build this brain tumor detection software. So, can you guys hear me?
Yes, we can hear you.
All right.
The AI program is like mathematics. I see the line of intersect.
So,
Can you express it?
so image diagnostics through image analysis, and then TensorFlow. As I said, TensorFlow is a powerful open source library for machine learning. It provides flexible and efficient framework for building and training various models, including image classifiers. All right. So TensorFlow is free open source. I think most I've never seen someone pay for a programming library before, except like companies like Google, Amazon, Microsoft. They have to pay for it. Apart from that, people like us we don't pay. But I remember once I met with the um I met with the president of Python. All right. Then I was asking her these questions like, so how do you guys fund Python? And then she told me like only companies like Google, Amazon, and the rest pay for AIM for Python. The rest of the guys don't pay for it. Basically, get it for free. All right. So they put in that structure so that those big companies will pay while we use it for free. All right. Key benefit of TensorFlow is it has high performance for complex computations. It has large community support, and then scalability for large data sets. Scalability for large data sets. Okay, so um, so I'm gonna be explaining this code. I'm gonna give you guys the code right now on the GitHub, right? So what are we doing here? what are we doing here? Firstly, we're importing our libraries. All right. We need NumPy, TensorFlow. So you import TensorFlow. But if you want to install TensorFlow, it's very simple. All you do is just for for Google Colab is installed automatically. But if you're using your laptop, you can just do pip install TensorFlow, and that's as simple as that. If you're using your terminal, just write pip install TensorFlow, and you'll be able to install TensorFlow and pip install NumPy. All right, and then pip install matplotlib. These things are things automatically installed on your lab. If you're using Colab to learn. All right. Okay. So for this, we are going to be using a data set called CFA10. So this data set has a lot of images. They have a lot of images, and it is it is just, you can access it without, you don't need to download it, you don't need to like stress. But by Monday we are going to be using a real, we need to like, we are going to a lot of hard things, because we need to like get like 500 2,000 images that are not being compressed and are not. This is the data set we are going to be using. I'm doing the data set here. I'm trying to look these are our trend image, our labels. So each of the image is going to have a label that I told you guys. So we map labels to the image, and also the test image also gonna have a label. Then we load it, and then we normalize it. The same thing I told you guys last week. It also happened in TensorFlow. We normalize the trend image and the test image, which is gonna be our trend image divided by what? By 250, by 250, 255, and also by 255. So let's do this. Let's print this so you guys see how the trend image looks like. I'm gonna do print trend image. Sorry, 1 minute. Trend image. Let me just do this. So you will see that we are loading the image directly. This is the image. This is the numpy array of the image. All right. So basically, what we are doing is that we pick all the image, we pick the image, and we divide it by 255 to normalize it. All right. And I explained why we are doing this last week to you guys. Um. So after that, we just need to check the classes, right? For this, we are going to be using class airplane, automobile, that's phone. So we are going to train an AI model to detect airplanes, automobile, which is like all these little cars, bird, carts, deer, dog, frog, or sheep, truck. Is what we are going to be working with, right? So this function here just helps you to plot the images. This function helps you to plot the images, and then we are going to be passing in our trend image, our our trend labels too, which we got. All right. So right here, what I'm doing is I'm trying to plot the first 25 image. That's why I'm putting it in this range. You can put any number here, like you want to plot like 12 images, it will give you 12 of the images in our data set, and also the labels for them. So these are the labels for each of what we are seeing. All right. And then the main thing. So this is our convolutional neural networks, which I explained to you guys last time. So I remember telling you guys that we need to define our class, our filters. We also need to define the input shape, all right, which always come from the image. So for example, this image, The input shape of this image is 32 by 32 by 3. What does by 3 mean? By 3 means that this is a colored image, RGB. I explained this to you guys on the first 2 weeks when we started this course. So um 32 by 32 by 32 RGB. All right. And our activation function, we're going to be using relu, and then we are passing it a filter. So this is the filter that we are using. Our filter is going to be a 3 by 3 filter. This is a filter, all right? And this 32 means the amount of filters we're using. So we're using 32 filters in this first layer. So what that means is these 32 filters, each of them, they are going to be learning for different things. They're going to be learning, maybe this one is learning for the leg of the horse, this one is learning for the head, and the rest of the things. All right. And then after this conv layer, which we apply max pooling. I explained this to you guys last week. We apply max pooling. After applying max pooling, we do the same thing again. We After applying max pooling, we add another layer. We do the same thing again, but this time we are using 64 filters, 3 by 3 activation function value. We apply max pooling again. We repeat the same thing. After it, we now flatten it. We flatten it here in TensorFlow with model.add layers.flatten. Right? So if we look at this, we're adding conf 2D layer because we are working with a 2D. We're not doing like 3D image classification. All right? If you're doing 3D image classification, then we use 3D. So max pooling 2D. All right, layers of max pooling into the layers of max dot conf 2D to add our layers. And then after that, we flatten it, and then lastly we add our dense layer. This dense layer is what is going to help us to, that is the main neural networks model right now. This one, the dense layer. We first of all start with 64 node, and then we apply 10 node. That this is going to be the last layer, and that's it. So we use model.summary for in TensorFlow, and this is going to help us to create for us our neural networks model. So if you can look at this is the first output shape we had. It was 30 by 30. And then after we applied max pooling, our shape is 15 by 15. That's reduced it by 2. Then after we apply max pooling, we added another conv layer. We got to 13 by 13. We apply max pooling, we got to 6 by 6. We keep on doing that until we flattened it. All right, I think I explained to you guys what we do to flatten it. We multiply um, our pixels by the shape, and then we get this. All right, and then we get our dense layer, our final dense layer, and this is the total parameters. Then and then and then lastly we compile the model. So this right here is what helps us to compile the model. All right, so optimizer is our TensorFlow our optimizer which we are going to use. There's a lot of optimizers. We can use stochastic gradient descent, but the best that is always used is Adams, right? There's Adam, there's a lot of other optimizers, and then we are calculating our loss function with this TensorFlow.losses space categorical cross entropy. So I remember telling you guys last time there are a lot of loss functions we can use, mean square error, a lot of them. It depends on the problem you're solving. Most of the times when we are solving issues that has to do with binary classification, you see people use like um, um, people using different type of loss functions, right? And then after that, we train the model. Very simple. We just run model.fit, and then we train our image. We put in our train images, put in our train labels as a label for the image. we mentioned the amount of epochs, how many times we want to run it over, and then our validation data. Now, validation later, I'll explain to you guys what this does next week, but don't worry much about it. Um, then we train, and then it runs for 10 epochs. And after running, we evaluate the model, test on the we check how best our model is doing, right? And that gives us that we add 0.7% accuracy. Then the training loss was 0.86. And then what I did here is just to visualize the training result. So I plot the training accuracy versus the epoch. So the more the epochs, the more the accuracy was increasing, and also the validation accuracy. Don't worry about validation. I've not explained to you guys what validation means, but by next week I'm going to explain everything for you guys. So I wanted to give you guys like a breakdown of TensorFlow. All right, and then this is also the validation, the training lost based on the epochs. Then I made prediction. So what I did here was just I used TensorFlow model to predict. I pass in a test image. Then I'm predicting on the first. I'm just printing the first prediction. So and then I visualize the prediction results. So this one just helping me to. I'm trying to use a lot of images at the same time, and then I'm putting different classes and trying to check if it's getting it correctly. It is this the y at minus y, right? So our our label, then we check if the A is actually getting it correctly, and then we got this prediction, which is correct. But in the real world, when we are building real things, when we start building like real projects, this ideally is not really going to give us correct results. But this is like a breakdown of intro. There are a lot of other things that we need to do. There are a lot of things there. We need to apply a lot of things. We need to apply dropout and the rest of the thing. We need to annotate. We need to augment, right? But this was just like a little bit of an intro to put you guys through TensorFlow, and I expect you guys to go and run this, learn from it on a Monday. On Tuesday, we'll build um a traffic light, a traffic sign detector. But that one, I'm not gonna be using a collab, so I need you guys to master this collab because I'm gonna be coding everything with VS Code ground up, installing everything, and will be flowing. So if you know anyone that has not been in the class, I think Tuesday class is a class that no one should miss because from Tuesday class going on, would not be using collab, so it will be hard for people to get like get the code that we've been learning with, and be saying like I want to get the code and go and do it myself. Because going forward would be hard coding everything, and I may not be able to like put everything in collab. All right, so that was it for today. I didn't want to go too deep. I wanted to make sure I, I take you guys through everything, at least the first intro to TensorFlow. And I'm not explaining most things deeply because I don't feel like I should explain it deeply yet until Tuesday. And we are building something really real, and by then which you guys don't know yet. But with this, you have the basic understanding, and you can go and build your image classifier and play around with the neurons, play around with the wait, you guys have not been seeing my screen.
Really?
Have you guys been seeing my screen?
Yes, you have been
Okay.
seeing your screen.
Yeah, play around with the network, create 50 50 different networks, see how it give you different results. All right. Um I'm really sorry for the rushing. I didn't expect to stay out for this long. I'm literally in someone's shop right now. The guy is chasing me away. All right. Okay. Do you guys have any question? If it's not like something really serious, I think you can just drop on the Discord or you message me on WhatsApp. I would um I'll still
Okay,
I would
sorry,
get